All right, here's just some review questions. Here's where I'm pretty sure where all of those questions come from, which sections come from. Here's question number 18. It's a log question. Radioactive has a half-life of 1450 years. If they tell you that, then in our formula, this one, P0e to the kt, they're giving me the time, that's 1450. But then when they say half-life, they're telling me what the first number and the last number is. So the first number, you can pick any number you want, like say 10. But if it's a half-life, that means after 1450 years, they got half of that left. So if you start with 10, then half of that would be 5. So this is how much you end up with. This is how much you start with. Okay, e to the k times 1450. So now the thing I'm trying to solve for is what it's not an interest rate, but it's that rate of this one, it would be radioactive decay. Okay, so to solve, I need to isolate the term or the factor that has the variable in it. So I'm going to divide both sides by 10. So in this, I'll get a half is equal to e to the k times 1450. Solving for an exponent, I can change this to log form. So log base e of a half is equal to k times 1450. Divide, and log base e is the same as ln. So ln of a half divided by 1450, that'll give you a k value. Okay, so solve for k, it'll be negative 0 point something. Then they ask the question, how many years? So they're going to be looking for time for a given amount to decay to 80% of that amount. So I need to use my same formula, e to the kt. This time I'm looking for t, but I now know k from here. And then they said, how long until it's 80% of that amount? So not 50%, 80%. So I would think it would be less than 1450 years. I guess I'm not positive, but to decay to 50%, it takes this long. So to decay just to 80%, it shouldn't take that long. Anyway, so again, I don't know how much I start with and end with, but they tell me 80%. So that means I'm starting at 100% and I'm going down to 80%. E to the k, that's my number from down here, times t. And then to solve, you do the same thing as we did over here. You'll divide both sides by 100. So you get 0.8 is equal to e to the whatever k was times t, and then change to log form. So log base e of 0.8 is equal to whatever a k value is times t, divide by that k value, etc. Okay, that's a good question. I like that one. Okay, here's a trig question, radians. A wheel with 15 centimeter diameter. Oh, I don't like that. Let's change that right away to radius. Is going 36 revolutions per minute. To the nearest meter, they want to know what the linear speed is. So this is an angular velocity, and what I'm looking for is a linear velocity. So I'll be using this formula. Okay, now one thing I know about radian, or about my angular velocity, is it must be measured in radians per time. But I've got something that's in revolutions per time, so I need to convert that. Let's maybe do that first. So our angular velocity is 36 revs per minute, but I want to multiply it by some ratio that's going to convert it into radians. So radians, I can say 1 revolution is the same thing as 2 pi radians. So my revolutions cancel. If I multiply that, I get 72 pi. If you wanted to multiply by the 3.14, you could too. But that's in radians per minute. So this is what I can put in my formula over here. So my velocity is equal to radius is 7.5 centimeters times the angular velocity is 72 pi radians per minute. Okay, So if I multiply 72 pi times 7.5, I don't have my calculator with me. You can do that. 72 pi, and that'll be radians per minute. So 3 times 210 times 7, I don't know, 1400 or something, 15, 1600. Now, they do want to know what the speed is in meters per minute. Oh, hold it, I forgot my centimeters right here. Here, when you use this formula, the radians cancel out, and so you have centimeters. Well, the radians sort of disappear. I haven't figured that out yet. Okay, so centimeters, my velocity is centimeters per minute, but I need to convert it to meters per minute. They want meters per minute. So to convert centimeters to meters, there's 100 centimeters in every meter. So centimeters will cancel out, and so I just go 7.5 times this divided by 100, and that'll give me what my linear speed on a point on the rim. Okay, last question, solving a trig equation. I'm looking at here, I see two terms. I'm looking for a common factor. So I can factor tan x out and be left with 2 cos x plus root 3 is equal to 0. Now I have two things multiplied together to give me 0, so one of them's got to be 0. So either tan x is 0 or 2 cos x plus root 3 is 0. So tan being 0, I know that tan is y over x. So tangent is 0 whenever y is equal to 0. So y is equal to 0 on the unit circle, either here or here. So I would say it could happen at 0 or pi or 3 or not 360. Oh, you could write that, or 2 pi, etc. Now here they say you can include 0, but because of this bracket right there, you can't include 2 pi. So 2 pi is out. So this is the only range they want to know information about. So it's 0 and pi. Now on the other side, I can move the root 3 to the other side, divide both sides by 2. So I get cos x is equal to negative root 3 over 2. And then that's on my chart. Or if you memorize the triangle, you can figure that out too. But the cos of, let's see, 30 degrees. So the cos of 30 degrees is root 3 over 2. So then notice I sort of disregard that negative while I figure out the reference angle. But now once I have the reference angle, that it's 30 degrees, so it could be 30 degrees off this x-axis, 30 off that x-axis, 30 off this one, or 30 off this one. But now I go back to this negative and say, well, where is cosine negative? And cosine is negative in these two quadrants here. So the only angles that I'm going to say in my answer, it can't be this one because that'd be positive, would be this angle. So that would be 180 minus 30, or 150. And this angle to there. So that would be 180 plus 30, or 210. So x is 150, or 210 degrees. Oh, they want it in radians, so I can convert those to radians. This one would be 7 pi over 6, and this one would be 5 pi over 6. All right, hopefully that helps you with those questions. Good luck on the test.